So we're looking now at optimization of trig functions, so finding maximum and minimum values. This video covers how to analyze a function without using your GDC. So again, none of this is new. You've covered this all with previous calculus. We're just now doing it with trig functions. So first thing we have to do is find the x and y intercepts. Right? The y-intercept is going to occur when x equals 0. The x-intercept is going to occur when y equals 0. So we're working our way through that. I've done the solution here just to save a bit of time in this video. You can pause it, have a look, go back if you need to. So all I'm doing is substituting in 0 into sine of x and cos of x, and using my knowledge of the unit circle, when x is 0, okay, at this point my sine value is 0, the y coordinate, my cos value is 1, the x coordinate. Okay, so that's all I've done there. That gives me a y-intercept of 0, 1. Moving on to the x-intercept. The x-intercept, we have to make the value of the function 0. So we've got 0 equals sine of x plus cos of x. In order to solve this without a calculator, you've got to rearrange the equation. Basically, we want just one single trig function. And so we divide both sides by cos, in orange there. Over here, cos of x divided by cos of x becomes 1. Negative sine of x divided by cos of x is negative tan of x. And so that gives me this equation to solve. At this point, we have to use our understanding of solving trig equations, all right, because there's potentially more than one solution here. If we go to our exact value triangle, the angle that will give us a magnitude of 1 from cos is pi on 4. So that's our basic or first quadrant angle, meaning that the angle here is pi on 4. We now need to place this in quadrants where tan is negative, and I've done that there and there. Okay, so what that tells us then is the first angle, this one here, is pi minus pi on 4, and the second angle, this one out here, is 2 pi minus pi on 4. So that's 3 pi on 4 and 7 pi on 4. And so we have two x-intercepts, one at 3 pi on 4 and one at 7 pi on 4. Alright, so that's part A, our intercepts. The next one asks us to find the intervals on which f is increasing and decreasing and the relative extreme points. The order of that question is not the order in which I'm going to do it. The very first thing I'm going to do is find those relative extreme points. So, going down to B. Because we're looking for relative extrema, that means the gradient is going to be 0 at those points. Because of that, first thing I have to do is find the derivative. The derivative of sine of x is cos of x, and the derivative of cos of x is negative sine of x. And we set that equal to 0. Solve this in a very similar way to what we did in the first part, finding the x-intercepts. And this time we end up with tan of x equals 1. Same basic angle from the exact value triangle, but this time the quadrants that we're dealing with are there and there, where tan is positive. So pi on 4 is a solution, as is pi plus pi on 4. So pi on 4 and 5 pi on 4. So with that, we can now do a sine diagram. We know that at these values, the derivative is 0. Okay, and now we need to check the values in between. Now this is fairly easy to do with these. Remember, we're testing the derivative. So that function. So I first of all want something in that region there. 0 works. Cos of 0 is 1. Sine of x is 0. So the gradient would have a positive value there, positive 1. Now I'm going to look at this region. Okay, what's a number between pi on 4 and 5 pi on 4? Easy one to work with here. Pi. So if I substitute pi in there, then cos of pi is negative 1. Sine of pi is 0. That equals negative 1. So in that region, the sign is negative. And we've got to do one last one. Something in this region here, an x value in that region would be 2 pi. So if I substitute that in, cos of 2 pi is 1, sine of 2 pi is 0. That's 1 minus 0, which is a positive value. Okay, and so greater than 5 pi on 4, the graph is increasing. Okay, we have a positive gradient. So, when is it increasing? Two regions. When x is less than pi on 4, and when x is greater than 5 pi on 4. However, we have a domain restriction. Okay, so remember 0 and 2 pi were the values we used. So that's fine. Nothing changes there. That just has an impact on those regions on which it's increasing. So it's 0 to pi on 4 and 5 pi on 4 to 2 pi. Where is it decreasing? It's decreasing in this region here. From pi on 4 to 5 pi on 4. Okay, so that answers that question, but we haven't quite found the relative extrema yet. We know the x values when they occur, but not the y values. So I have to evaluate going back to our exact value triangle. Sine of pi on 4 is 1 on root 2. Cos of pi on 4 is 1 on root 2. So that's 2 on root 2. Or root 2. Five pi on 4. Well, this time we're in this quadrant here. Sine and cos are both negative there. So we have negative 1 on root 2 plus negative 1 on root 2, which is negative 2 on root 2, or negative root 2. Okay, so we now have a relative maximum. Okay, how do I tell which one's the maximum? So increasing, 0, decreasing. There's our maximum at pi on 4. Decreasing, 0, increasing. There's our minimum at 5 pi on 4. Alright, the next part. We have to give the regions on which it's concave up and concave down and the inflection points. So concavity refers to a second derivative. The second derivative, derivative of cos of x, is negative sine of x. Derivative of sine of x is cos of x. Same process through here of evaluating, and you end up with this function here, which we've actually already solved. Okay, what this tells me, okay, because they were the x-intercepts, that the x-intercepts are also inflection points. Alright, checking the concavity on a sine diagram. A number 0 and 2 pi. So a value in this region here, pi, okay, negative sine of pi minus cos of pi. That would be 0. minus negative 1, so positive, and you'll find when you do your second derivative test that it will be negative in those regions there. So, what have we got to plot? We've got to plot x-intercepts at 3 pi on 4 and 7 pi on 4. Okay, 3 pi on 4, 4 pi on 4, 5, 6, 7 pi on 4. We have to plot a y-intercept at 0, 1. There. We have to plot a relative maximum at pi on 4, root 2. And we have to plot a relative minimum at 5 pi on 4, negative root 2. Okay. There's the function. Does it meet all of those criteria? Is the graph increasing between 0 and pi on 4, as shown here? And from 5 pi on 4 to 2 pi on 4? The answer to that is yes. Okay, it's increasing there, and it's increasing there. What about the concavity? Does that work? Is it concave down between 0 and 3 pi on 4? Well, yes it is. Is it concave up between 3 pi on 4 and 7 pi on 4? It is. We haven't quite finished because we need to sketch up to 2 pi, and so you should be plotting this coordinate as well as the end point, and to get that you would sub 2 pi into the original function, and it's going to be 1. Okay, is it concave down through that region? Yes, it is.